Okay, while I get settled, I need y'all to turn to page 10 and see what you can come up with for trying to find the value of x for each of these exponential equations.
So I didn't do it Tuesday, Monday night, that was their homework, and then they got the problems up Tuesday. Is this real number?
Down, Dan. Let's specify your correction. So the grade on the top is how you did on that assignment, which for the most part, it either was a 10, an 8.5, a 7, or a 5, and then I have slips for the people that didn't, like, I still need them from you. 10 if you followed all the directions pretty much correctly, and 8.5 I bumped you down 1 if I felt like maybe for the reflection you didn't follow completely the directions on like completely explaining, or if like maybe in your work you still had a mistake or didn't completely finish the problem, okay? A 7 if you're missing stuff from maybe both of the sections, your work and the reflection, and then it will be a 5. No one has a 5 yet, but it will be a 5 if I like never get it from you type of thing, okay? So I'm going to give out reminders to the people I haven't gotten from yet that currently it's just late work that you can still get into me in my inbox just like you would a problem set, okay? So again, remember, try to get that in because this assignment is not meant to hurt your grades. It's meant to help you out, but all you got to do is take the time to do it. And all I asked for was one of them so that you really had the time to do that correction well rather than rushing through it, okay? Stephanie, did you need a problem set? Okay. Thank you guys for waiting for me. I'll be done in 1 second. So much to do, so little time. Why not hinges up? Okay, here we go. Thank you guys for being focused. And thank you to those of you that have had everything turned in. Good to go. Okay, here we go. Oh. No, here's okay, cool. the top. Let's take a look, see how we felt about these. You got the first one, Diego? Oh, and then I also don't have yours, but I had one that said DC on it, and I thought it was yours, but it ended up being yours. What are the chances? I literally gave you, like, if you look in the grade book, you have a grade for it, but then in class he was like, Miss, I turned mine in. And then he was like describing it, and I was like, so then I'm gonna have to change yours. Sorry. But I didn't have a slip for you. Your slip went to Dennis instead. Oops. I don't know, I was like, you would write in code like that, and I wouldn't know who it is. DC, very difficult. Anyone see my clicker around the room? Oh, thanks. Perfect. Okay, so here we go. First one, 5 to what power would give you 125, Israel?
3.
All right, he came in late and he still got his work done. Thank you, 3. All right, next up. Kevin?
4.
4. Oh, wrong one. No one saw that. 4 for this one, and Lyria, last one.
0.
0 for that one. Anything to the 0 power is equal to 1. So whether it's e or 100 to the power of 0 would be 1. So that's just something we need to recognize when we're doing these. Okay. The reason we did this is because today, when we do logarithms, a lot of times we're going to rewrite them as using exponential functions, and we're going to be thinking something to something power equals something, and so we're going to be basically doing this line of thinking right here. Okay, so a few announcements. Your problem set that's due on Monday, just so you know, if you've looked at the back, you could have done everything through the little logarithm problems at the bottom, and after today you should be able to do all of those. So tomorrow's lesson we're doing graphs of logs, but I actually am going to wait to put those questions on next week's problem set, and so after today's class you actually should be able to knock out the whole thing if you don't want to do anything over the weekend, okay? Cool, and then your quiz is on Wednesday, your first one for Unit 3, and on that I'm going to cover anything from what we started with on Monday on day 1 of the unit, all the way through Monday after the weekend. So I'm not going to put anything on Tuesday because that's the day before the quiz. So anything you've learned this week, you learn tomorrow or you learn on Monday could be on that quiz, okay? I always get like, what's on it? So I'm just trying to answer that question. Everything through Monday. Okay. Properties of logarithms. Raise your hand if you've ever heard of this thing before, a logarithm, even if you don't remember anything about it, if you feel like you've heard that word. Okay, lots of us, cool, hands down. So hopefully today, maybe some of us can share some things we already know about logarithms, and even if you've seen them but you don't remember anything about them, then that's okay, we're going to do some refreshing today as well. Okay, so right below your do first, let's pick up where it says explain. Remember, if you recall, remember from our lesson about inverse functions, think way back to Unit 1 when we learned what an inverse function is. We'll talk about that in a second. Inverse functions. Remember from our lesson about inverse functions that functions that pass something we called the horizontal line test are called one-to-one and have inverses that are also functions. So back in Unit 1, when we said, is there an inverse function, we did something called the horizontal line test. For example, if this was our function, we'd say, oh, it failed the horizontal line test, there's no inverse, right? If it was another type of graph that only passed through once, we said it has an inverse. And then what did we do to find an inverse? It has to do with switching something. Anyone remember? Tom?
The x and y values.
The x and y. So we took x, so we took y, and we switched them. The inverse was like the opposite. We switched x and y, okay? So today, we're going to look at what we've looked at all week. Notice that exponential functions, b to the power of x. Remember this graph? B to the power of x? Right? That's an exponential function. It passes the horizontal line test. Therefore, it's one-to-one, and its inverse is also a function. And so because it has an inverse, we call that inverse something special. We call it a logarithmic function, and we have some like different notation for it. So if someone asks you, what is a logarithmic function? What's a log? you can, like a good answer to that would be, it's the inverse of our exponential function. It's the opposite of our inverse of our exponential function. Okay, so you don't have all this written down in your box, right?
Yeah.
You've got the picture. So like you guys probably noticed, I'm starting to leave like more blank spaces in our notes where you guys are kind of processing on your own and summarizing what you feel like is important. So I'm going to kind of talk through what a logarithmic function is, and you guys jot down whatever you feel like you need in your notes. So we know that the inverse of an exponential function, we just said, we call the logarithmic function. So that's just our basic definition. A logarithmic function is the inverse of our exponential function, b to the power of x. What is the logarithmic function? It is the inverse of our exponential function, b to the power of x. Okay, that's what we call it, logarithmic function. But how do we write that in math? It's written as this, f inverse of x, the inverse is log base b of x. And we read it, I actually just read it, so I said it this way. We read it as log base b of x. So you don't say log of b big X, right? You say log base b of x would be how you would read that. So for example, how would I like say this if I'm like reading a paragraph and I see this? How would I say this? I'm not gonna say log little 2 big 8. What am I gonna say? Can you wait, raise your hand because poor Lyra is back there. She's like, and then we're just shouting out. Brandon?
Log base 2 8.
Cool, right? That's how you would say it. We're gonna practice saying it today. Okay, cool. So what is it? Let's take a look at our picture right here. We're gonna look closer at this tomorrow. We're gonna do the graphs tomorrow, like I said, but kind of a quick preview. This, on my graph, because mine's in color, this black line right here, it says is b to the power of x, and it should look familiar, right? That's this guy, b to the power of x. So this intercept right here we should know is what? Anyone? Call it out. 1, 0, 1. It always crosses through 0, 1, no matter what that base is, as long as the base is bigger than 1. Okay. Now remember we said that the inverse is when we take x and y and we switch them. So if this is our exponential function, the inverse would not have 0, 1, it would have 1, 0. And so that's where you see, and we're going to examine this closer tomorrow, you see 1, 0 on this graph. And all these little points, if I switch them, I end up with this blue line right here, and that's my graph of my log, or my inverse. Okay? Cool? So tomorrow we're going to take this graph. I'm going to have a new poster. If I can find some more poster for it, I'm running out of poster. Ooh, I'll do it on the back.
Yeah.
Actually, we'll probably want to see both sometimes.
Yeah.
I'll do the back of another one. But anyways, or I'll go to Walmart. But either way, we'll be taking that graph and we'll be shifting it, stretching it, all the things we did at the beginning of the week with the exponential graph, okay? Today, we're going to pause on that. We're going to just talk about how we evaluate something like this. Like, if I type this into my calculator, I'll get an answer, but how would I do something like this by hand, okay? So let's talk about what this notation means. And by doing that, we're going to look at the next little box where it says relating logarithmic and exponential forms. Okay? When you see a log like this, log base b of x equal to y, some answer, okay? We need to kind of translate that in our brain because it's a language that we're not as comfortable with, right? Because it is related to the exponential function, what this means is the same thing as b to the power of y equals x. Notice this right here. We can go back and forth between those, okay? So, for this one, I would be thinking, I'll tell you that the answer to this is 3, because 2 to the power of 3, my answer is equal to what? 8, which is what my log was of, okay? So when I'm solving these, I'm going to actually, a lot of the time, like rewrite it like this to solve, okay? So I'll say, log base 2 of of 8. Let me think. 2 to what power would be 8? Think about it. 2 to the what power?
3.
We just did it. More people? 2 to what power?
3.
The third power is 8, and so then you'll say, then the answer to log 2 of 8 must be 3. Okay? Okay, let's look at one more example together and practice this. So, here is a log that we want to evaluate. Eli, can you first just read this log to me, practicing how we would like read it or say it?
Log base 3 81.
Perfect. Log base 3 of 81 is how we would say it, okay? But that might not mean a lot to us, okay? So he just read this part, log base 3 of 81. But what does that mean? The question being asked is 3 raised to what power is 81? So it's this number, 3, your base, to what power, that's what we're looking for, our answer, is equal to 81. So think about that, or if you want to reference my power poster over here, 3, raise your hand, I've got Giselle, and I got Melanie, who else do I got? 3, to what power is 81? I got Deanthea, Israel, Sandy, Kevin's here, Dario, Lazaro's got it. This zone, not working yet. Let's see, 3 to what power, here's all my powers of 3, 3 to what power is equal to 81? Felix? Woo! To the power of 4. Okay, so this is equal to 4. So 4 is our answer to that log. Literally, if you go right now and click on your calculator, control log, there's also a button on your calculator, it'll pop up and you can type in the 3 and the 81 and your calculator will give you 4. But on a non-calculator section, you would need to know what that means to find it by hand, okay? Okay, let's talk through a few more of these because some of them are kind of funky. I chose some different examples and then you're going to do some practice. So next one, can someone help me? I'm going to read it like Eli did. Log base 7 of 149. Can someone else, this time instead of me, like translate that for us to an exponential form to help us to solve it? You don't have to give me the answer, but just how would I translate it? Deanthea?
7 to what power equal 1/49?
Okay, so this is what the question we're asking ourselves, and it helps me to write it down because I'm bad at doing it in my head, so if it helps you, you can write it down too. 7 to what power would give me 1/49? Tricky, because it's like fraction, but we've talked about this a lot, so I see some hands. Diego, you think you got an idea? Good. Why? Someone that is like not sure where in the world he got that, someone explain how he knew it was a -2? Kevin?
Because 7 squared is 49, so to find the fraction of 42 to a -2.
Cool. So 7 squared is the 49. To get it on the bottom, we need it to not be a +2, but a -2. Nice. Cool. I know a lot of people stamps. I'll be there in a second. Okay. Next up. Whew. Stick with me. I've done these a lot. One class. Okay. Let's translate it. 5 to what power is √5? I don't know. So let's think. We're dealing with powers here. So I want to rewrite this as not a square root. I want to think if I can rewrite a square root as a power, which I can. Does anyone in here remember how to rewrite a root? Like you can rewrite the square root of 25 as 25 to the something power, or cube root of 8 as 8 to the something power. What would I put as those powers, Brandon?
1/2.
1/2, or like this cube root would be like having 1/3 on our 8. So our fraction exponent, we learned that last unit or the unit before, we talked about roots, and we talked about how a root is the same thing as having a fraction exponent. So I can rewrite this as 5 to the 1/2 power. Yesterday we learned that if they have matching bases, what's true about our exponents? They're the same. So what does my like mystery question mark number have to be? 1/2, right? If they have the same base, then the exponents must match. So this exponent has to be 1/2. Okay? So it'll be 1/2. And last one, I bet a lot of you guys can do this one or have already done it. Anyone got the last one because they already looked? Deanthea's got it. I like it. I hear Melanie. 2 to the power of what equals 2? 2 to what power, Deanthea? 2 to the first power would equal 2, right? So 1. Okay, y'all try that out. 4 more. Go ahead and try them with your neighbors, see how you do. While you're doing that, I've got to start checking, like I mentioned, calculators and things. So I'm going to come around and check for calculator and all the things that I need to do. So you guys are knocking down 4 problems. I'm probably only going to do the front 3 tables right now. I'll do the next 3 in our next round of practice.
Power of 0 is 1.
Also, I got to so, do you have both one? You don't have one? Can I see your marker?
That's for the
Do you have a calculator?
power goes to
Oh, really? No way.
Good. Do you have a, oh, I see yours. You keep looking. Let me know. I'm gonna put in this. You got a belt over there? You got a phone over there?
Yeah.
Good job. I see it. Do you have a belt? Sweet. Do you have one? Wonderful. And there's a full on under there.
We're gonna be.
Do you have one too? Cool. Okay. Next up. Calculator. Belt? Polo?
Since it has the same base, it has to be the same. So then
There's one under there. I see it's brown. Okay, and a belt. Nice. Okay. Get extra marker because I gotta write it on there too. Okay, let me see. Belt and a polo. Nice. Got one. Got it. Oh, no. Okay, good try. Can I see your marble card? Oops, I wrote down Juan Marble instead of one. Because I was trying to say that you don't have one. Okay, and then, do you have one, Jamie? What are you missing? Shirt? This is so eye-opening. They told me that I need to do this 2 times a week and I've learned so much. Oh my gosh. This is why I'm doing this. This is so funny to me. I'm sorry if it's not funny to you all, but it's funny to me. It'll be okay. Just so you all know, I have to check twice a week. Sometimes I check a week. So when am I going to check again? No, that's not this week. That means I got to check tomorrow too. Because I haven't checked. I was supposed to check twice this week and I haven't. And so I'm running out of time, so I'm checking today. Okay. A few more seconds on this, then I might come check the back later. Yeah, I think I said you're good. Okay, so this is 5. Do you understand this line? 5 to what power is root 5? Because this is the same thing we do every time. 3 to what power is 81, right? Okay, so 5 to what power is root 5? Now, I have to write this with a power because I need to be able to compare and see the power. And a square root is the same thing as a power of a half. And so, if my bases are the same, then this question mark has to be a half because they have to be the same. Okay? Okay, we're going to check them, see how we did, and then I will get to the back row when we practice again in a second. First up, I'm just going to pop around to people. We're not going to talk about it much because I think most people are going to do okay on this, but please call me over if you feel like you don't know why we're getting the answers we're getting. Raise your hand just quickly for A, B, C, D. Any that you want to share? D, we might have to talk about. Sandy, A?
3.
3. All right, B. Who's got B? B. Lirio.
3.2.
3.2. So this one, if we have 4 to what power is 4 to the 3.2? Like we said yesterday, matching bases means your exponents have to be the same. So our question mark has to be 3.2, right? Okay. Next up, Edith. -5. Cool.
She participated.
Okay. This last one gets kind of funky. So let's talk through and see how we feel about it. I still always want to start by translating it. So can someone just tell me what I could write down in exponential form, and then we'll figure out the answer together. Nobody? Christina, go for it.
16 times the base and 2 to the half.
Okay, cool. And she already even wrote this. She kind of like skipped a step. Do you agree 2 to 1/2 is the same as root 2?
Yeah.
Like we did on the root 5 one earlier? Okay. So she rewrote this as an exponent to help her. And now, taking a look at this, since this is like a mystery number, kind of think about it like as, like you could use a variable. A variable is an unknown number, right? So this actually now looks very similar to what we did yesterday, where we had to solve an equation where we were solving for something stuck up high. What was our goal yesterday to do when we found something like this, Giselle? Matching our bases. Can we write 16 with a base of 2?
Yes.
Keep going, Giselle. 2 to the what power?
2 to the 4th.
2 to the 4th power. So I can rewrite this as 2 to the 4th power to the x equals 2 to the 1/2. So this is 2 to the, we multiply these, 4x equals 2 to the 1/2. Are my bases the same?
Yes.
Therefore, what do I know about my exponents? They are the same, they are equivalent. So we're looking for x that when I multiply it times 4, I get 1/2. So again, fractions kind of like sometimes make our head hurt. So this might be difficult, but let's stick with it. We would do what to get rid of the 4? Divide by 4. If you would rather multiply times 1/4, you can do that. But let's think about that. If I have 1/2 and I divide by 4, KFC back in the day, keep the first one 1/2. Change this to multiplication.
Yeah.
Flip this to
1/4.
1/4. Okay, K, F, keep it, flip it, change it to
1/8.
They just should make you memorize it that way because no one knows what KCF is, no one remembers. KFC, people are like, chicken! Like all my, y'all should see my 6th grade class. We used to be like, time for KFC! And I had kids like pretending to eat chicken over there like while they were y'all did that in 6th grade, you just forget how much energy you had. They were so excited. We did the marble clap every day before we started class. Like I would be like, how are you feeling today, marbles? And they'd all do it and like so loud, so loud. Oh, it was so fun. Do y'all want to do that tomorrow?
Let's do that now.
How are you feeling today, marbles?
Marvelous!
You're on video.
Oh, we recording?
Anyway,
Oh, no.
yeah, you're on video. Great job. Okay, so now x equals
Wait, what?
1/2 times 1/4. Cool. Nice.
Miss, no, I'm still confused.
Okay, so I know that last one was a little bit more challenging, but it's kind of mixing knowing how to identify what a log is by thinking of your log in exponential form paired with what we did yesterday, which is solving an equation where you have to match the bases. Okay? So combo deal you did yesterday and today all in one. Okay, let's go over a few properties. There's a few interesting things that happen in special cases with logs. For example, in part B, you probably noticed that because this 4 and 4 were the same, your answer actually ended up being exactly this 3.2 exponent, right? And so you're going to notice that anytime that happens, that those numbers match, we start kind of getting to a point where we just like say that they cancel and we know that we have the 3.2 or whatever's left, okay? So some of those are what we call like common properties of logs that we see a lot that we kind of just want to commit to our memory. So we're going to talk about a few properties of logs that are true and we're going to list them here. But first we're going to kind of think about why they make sense and then from here on out we'll just kind of accept them to be true. So first one, if I have log base b of 1, no matter what your base is, pick a number, any number. 2. Okay. Let's say we have log base 2 of 1. If I translate this, you're saying 2 to what power equals 1, right? What's it gotta be? 0. It doesn't matter what that number was, always, 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 your exponent's gonna have to be 0 to give you 1, right? So no matter what we have here for b, anytime we're taking the log of 1, your answer is gonna be 0. And so you can do those really quickly without writing it down like every time, okay? Okay, next step. If you have the log base b of b, if they match, let's think about that. We'll use 2 again. Log base 2 of 2. That means 2 to what power would be equal to 2? What's that always going to be? 1. If those numbers match, then we're going to start just like knowing that matching log base and what you're taking it of is going to be 1 every time. Okay? Okay, and if I have log base b of b to the power of x, just like we saw in part B on the last page, again, these are going to kind of like cancel, or if I use 2, depending on the space, log base 2 of 2 to the x, then I would have 2 to what power equals 2 to the x. These have to both be that same x value, right? Okay, so these will like kind of cancel. We end up with just x. Okay, and last but not least, similar to this one, if it's the opposite, if I have b raised to a log, we didn't see any examples like this, but if you take b and you literally like in your calculator, raise it to a log with a base b of x, same thing, because this and this base match, what do you think this is going to be equal to? Just x. Like you're just going to be left with x. The only clarifying point I'll leave for that one though, that I'm not going to discuss right now, but that one only works for x being positive. But I'm not going to go into all that, but we can talk about that. Okay, so y'all go ahead. I'm going to go to my back and keep checking things. And raise your hand if I owe you a stamp, because as I walk around I'll give stamps. You guys, I want you to do these 4 down here. I know I got a lot to do. You guys go ahead and do the 4 right below, okay? Go.
Did you put early action for?
Hands are cold.
Early action priority.
Okay, calculator. Don't even use calculator. Can you work right out? Can you don't have
Until you unzip and then.
do you have pretty shirt on for
Well, they have running systems like this up by in August.
The whole street is totally.
But you got belts on you?
Playing.
Oh, yeah. Yeah, and that, you have belts on? I'm checking uniforms, I gotta check twice a week, they told me. We have 4.
You got a belt on one, you got a belt.
Belts on it down there. Here it is. Hold on under that sweatshirt.
Chinchillas.
Okay, over here, let's see, calculator. Calculator. I owe you a stamp. Okay, and do we have a belt on? And we got that polo
I
belt.
used to put million
Nice.
one each day.
Nice. Well
I
done.
missed this.
Woo! You passed. Okay, moving on. Calculator. Belts. Nice. And shirts. Yay! Good job, team. Okay, and we got over here one more pass. Stamps. Who do I owe stamps to? All right. One for you. Or 2 for you? I think so. Yeah. And 1 for you. Lovely. Anyone over here? Nope. All right. Are we ready to check?
Yes.
No. Maybe. Are we ready to check?
Yeah.
Anyone need more time?
No.
I don't think so. Okay. Cool. First up, who's got it? Let's see. I still see a lot of scan hands. No one else wants to share? Cool. End of A2s next week. There's your participation time. Oh, wait, Felix, I owe you one too. You got your stamp thing? Dahlia. 3. Nice. Next up. Danvia.
For next one, right? B?
Yep.
4.7.
4.7. Cancel. Tyler, you're up. 2. And last one. Ehong. 1. I was looking at Edith, but then I go on Ehong. Just keep me on your toes. Okay. Feel good about that? Okay. Last thing. We're going to hopefully finish early. We did in my other classes, and then they got to work on their problem sets. So stick with me. 2 quick. On your page, it's actually only one of them's there, but I'm going to add on one extra thing, so we're going to like split this down the middle. But I'm going to talk about 2 special cases for the base of our log. One of them we call the common log. One of them we call the natural log. Okay? So think about, I'm going to do like kind of an analogy for the common log. If you think back to the square root and like the cube root, technically there's a little 2 on this root, right? Because it's the square root.
Yeah.
But we don't write it by convention because that one's like really common. You see it a lot, right? Yep. So it's just accepted. All of us know that we're looking for a number squared even though the 2's not there. Okay? For the common log, it's talking about a log that has a base that we see a lot, so much so that they actually just drop in and they don't write it, but it's still there. Okay? So a logarithm with a base of 10, we could write, you guys might think to write it like this, like log base 10 of 100, right? But actually we don't usually write that like that because it's what we call the common log. We see it so much that they often write it without the base. They would usually write this as just log 100, and everyone in the math world just knows that that base is what? 10. Okay, you might have seen that before. So every time it's not there, that's a base of 10. Therefore, if you see y equals log x, then you're thinking your base is 10. 10 to the power of y equals x. Okay? Whenever the base is not there, the base is 10. Okay, so let's go through those same properties because we want to get really familiar with the properties that we learned before, but now with the common log. So if I say log of 1, that's the same thing as log base 10 of 1, but I'm going to call it log 1 because it's the common log. Anytime I take a log of 1, what did we say that was going to be equal to? 0. Lovely. I'm going to try to get some more participation points, so raise your hand on these and then I can like identify who's speaking. Okay, for the next one, if I take the log of 10, technically that base is 10 down here too, so they match. And so thinking about your property from before, what would that have to be equal to? Lazaro? 1. Because 10 to what power is 10? 10 to the first power is 10, right? Okay. Okay, next up, log base 10, but we don't write it, of 10 to the x would have to be equal to what, Jonathan? X, because the 10's cancel even though you can't like see the 10 on the log, okay? And last up, 10 to the power of log x is going to be equal to what, Christina? X, because the 10's, again, same thing as before. And again, I'm just going to write that's actually just for when x is positive. Again, we're not going to talk about really why that's true, but you can write that. Okay. Now let's talk natural log. So that's the common log. It's very common. That's why we call it that. The natural log, we call the natural log because it comes from when your base is that number that we learned earlier this week, the natural base e to the power of x. And the reason we call that the natural base is because oftentimes, like in natural growth in nature of like, let's say like bacteria or something, like it would grow at the rate where your base is like 2.718, whatever that number is. It's very fancy. Okay, so e is going to be our base. Whenever that's the case, again, we're not going to write log base e of some number. Instead, we just write it as ln. Because the L stands for log and the N stands for the natural base. So you write it, you might have seen ln before. We write it as ln instead of log of e. Kind of like ln DeGeneres, except there's no e and there's not the second L and then there's not the other e and there's not the N. What? So, very different, but maybe it reminds you of her and you'll laugh for a second because she's really funny. Do you like Ellen DeGeneres? I feel like you'd like her because you're really funny. Okay, ready? Okay. Ready?
Yeah.
So, ln of 1 is another way to write log base e. We just write as ln. But again, no matter what our base is, raise your hand and tell me what ln of 1 is equal to. We just want to get really quick at these so that when we see them we know. Luis? 0. Nice. Okay. ln of e. It wouldn't be ln of 10, right? Because the 10 matched the common base. E matches the base of the common log, which is e. ln of e, there you go. 1. ln of e to the x. Edith? X. E to the ln of x. Giselle? X for x greater than 0. So later this next week when we're like solving equations, you're gonna have big long equations and then they'll pop in there like ln of 1. And you'll be like, and all you need to know is ln of 1, you need to be able to recognize that as 0 so that you can basically like cancel it out or it'll basically make your problem a lot simpler, right? Or if you see ln of e, you'll know that's equal to 1 and it'll make things a lot easier later down the road. Yep. ln is the same thing as log base e, but because it's a special one we see a lot, they don't write it like that. They write it as ln because it's a log. And it's the natural log, and so they just abbreviate it that way. Cool? Cool. Not ln DeGeneres. Alright, so y'all go ahead and flip the last 4 problems that you're going to do to practice with the ln's. All of these, if they say ln, have what base? All of these, that's the natural log. All of these, since they're ln, they're not the natural log, all of these have what base? E, the E number. Okay, so take a look at these, solve them. A and C, listen carefully. A and C, I want you to do by hand. B and D, I want you to just type into your calculator so that you can find the ln button because they have some kind of different answers that we're going to briefly talk about when we come back together. 2 by hand, 2 in your calc. Go. Stamps. So you do twice?
She's already catching up.
So no solution, and we're going to talk about why, but for now you can write that down.
These are negatives.
Because think about your growth graph.
Yeah.
It starts at 0, so that whenever you go to a -5, it doesn't go down there, right? There's no exponent.
There are no solutions.
You put it on, put it in literally your calculator.
Alright. do like.
Okay, I think that was enough time.
Where are you gonna go?
Here we go. We're still gonna get you time to work on your problem set. Someone to give us the answer for A and C, because they're quick. Someone for A and C. Well, Johnny.
For 8.73.
0.73, and for C?
6.
6. I think it's in the wrong order, so I'm gonna write it. Okay, cool. Now, let's talk about these guys. When you typed it in your calculator, first for anyone that's like, I don't know how to type that in my calculator, you're gonna press Control. See this little ln that's over the e to the power of x? Find it? Literally when you press Control and press that button, your calculator pops up with this and you can type in the -5 and see what your calculator gives you, okay? So on a calc section you could do that. Non-calculator, we want to like talk about it. So Diego, what did you get when you typed that in?
I got negative 1.62.
I think that's when you typed in a +5 and this was a -5. So that's quite. Sandy?
No real calculation.
No real calculation. So there's not a solution. Why? So let's talk about it. For now, that was on, like I told you, you could use your calculator, okay? But do not disengage right now. Keep your mind with me because I could give this to you on a non-calc, but we're going to talk about how you would do that. I didn't expect you to be able to do that, but now let's talk about it. Let's still translate this the same way we would before. ln stands for log base e, right?
Yeah.
So how would we rewrite this in the exponential form to help us to solve it? We would say what? Raise your hand if you can translate for me. That's what we've been doing all day. What would we do, Giselle? Okay, let me go back because I don't have many hands. Then Messiah, I'm going to have you take it, but let me see if I can get some more people. So for like this one, we said 5 to what power is 125, right? And then we figured out the 3 that way. That's the only step I want you to give me for this next one, is I want you to translate for me how would we rewrite this, Messiah?
E to the power of
Something.
x equals -5.
Okay, this is what we're trying to figure out. E to what power would be -5, okay? So let's think about that. We know not much about the powers of E, right? That's not one of the ones we have here that we know, like E squared and E cubed and all that. But we know that the graph of exponential growth looks like this, right? E to the power of x. Can this ever give you a y value, or can the function ever be equal to -5 down here?
No.
There's no value that I could plug in here and ever get -5, right? No matter what your x value is, you're going to get a positive y value. So that's why there's no solution here. This could not be equal to a negative number, okay? So we could have done that with our calculator knowing that our function couldn't be equal to a negative number, but we just had to like stop and think about it, okay? Cool? This guy, I could not give you on a non-calculator section because we would say E to what power is equal to 4. Can we have a positive answer? 4 up here? Yeah. And it's some random number because I don't know the powers of E, right? Like I don't know E to the whatever. So we can just type that into our calculator. I think you should have gotten 1.386
Yeah.
on that one. Yep. So if you in your calculator say 2.718 to the 1.386, you should get something around that. Because think about it, this is around 2. This is also like, I mean closer to 1, but also around 2, and what's 2 squared? 2 squared? 4. So it makes sense that it's around that much. Okay. Okay. Y'all have 1 minute. Really quick, glance at your problem set down at the bottom 3 problems that are these log problems to show you yourself how quick they're going to be. You could probably do 1 or 2 of them right now in 1 minute, or know that you should knock those out tonight and not wait for the weekend because they're going to be super quick and you are on top of your studies. Oh my God.
Is it?
everyone walk around like stamps, stamps. Call me over.
Very easy.
I don't know. Here, some people, what they do is